Hardware. Hardware is where we are. Learning about what goes on inside a computer. Who has never taken apart a computer before? Awesome. This will be fun then. First thing we're going to do is learn a little bit about the parts inside a computer on this thing, which is called the motherboard. This is the motherboard. The motherboard is the main circuit board for a computer. Everything else flows through it. The processor, the memory, your video card, your sound chip, which is probably on board but could be an add-on card if you want it to be. Everything requires this motherboard. Sometimes it's known as a main board. That's fine too, but typically we're going to refer to it as a motherboard. There are, in fact, daughter cards that go into some motherboards. We probably won't see many of those. We're going to focus mostly on PCs to start. When you go to build a server, it's built exactly the same way. You just sort of weigh your parts a little more carefully. So RAM becomes maybe more important in some servers, hard drives in other servers. You have to make those same decisions on a PC, so they're very, very similar. So starting with a PC, the motherboard that goes inside has places to hook the important components. Right here is where the processor goes, or CPU. CPU stands for Central Processing Unit. In our history portion, we looked at the Intel 4004. That was the first general purpose CPU. Wasn't the first integrated circuit. TI, Texas Instruments, was responsible for, or claims typically the first integrated circuit. The first CPU from Intel, the 4004, is the granddaddy of what goes in this thing today. So if you're going to stick a Core i7 in here, or actually what you'll see on this motherboard is this AM2+. This is not an Intel-based motherboard. Who's Intel's big rival?
AMD.
AMD. This is an AMD-based motherboard. There are other processor manufacturers out there. VIA is one. But for the most part, 99% of computers out there are going to come with either an Intel processor or an AMD processor. And while they are very similar in their capabilities, they do not work in the same machines. They are completely separate entities. Your motherboard and your processor have to match. Since this is an AM2+, we need to find a processor that fits in this socket. Only an AM2 or an AM2 Plus processor will fit in that socket, which means we have to buy one of those, and we have to buy it from AMD. Or rather, it's made by AMD. We can buy it from whoever we want that carries it, Newegg or Amazon. Yeah?
Why do all Gigabyte boards say like ultra durable?
Marketing, I would think. The ultra durable should, but does not necessarily refer to the capacitors. The capacitors which have had a tendency to go bad, they've got a redesign, and you'll notice these don't have that little crosshatch pattern on them, so they're less likely to pop up when they start to go bad. So these capacitors are higher quality. That should mean ultra durable, but I don't think there's anything that's stating this is what ultra durable is.
Yeah, mine says like 50,000 hours of, I don't know.
I wonder how many years that works out.
I think
to.
it's like 50 or 45.
You
Yeah.
should add.
Should add it up. You get a calculator, right? Look at that.
I don't know if my phone has one.
Technology.
50,000 divided by 24 would be 2,000 days.
Okay, divided by 365.
365.
years. Nothing about leap years.
5.7 years.
5.7 years is actually not a huge amount of years.
That is not.
My motherboard's going on 4 years right now, and it's got plenty of life left in it. I've still got a working motherboard for my last AMD machine. It's got to be 7 years old now. So that would be the goal, right?
Yeah,
that we never have to measure that sort of thing. It will always work.
Yeah.
Or measure it in thousands of years. or
But
something.
I don't think it'll happen because us as humans
Because of the number 7.
are always supposed to play.
Exactly.
I don't use.
All right, so this is where the processor goes. That makes this the CPU socket. There are differences between sockets and slots. Sockets typically are square, like this. This has pins that go down in it. Modern processors usually use what's called a land grid array, LGA. The LGA means that the bottom is not pins that stick out, but rather it's flat surfaces that kind of butt up together like that instead of pins that go in like this. The advantage there is that the pins will get bent. LGA can't. So it's harder to damage a processor that has a land grid array that connects like this. Intel's Core series, all land grid array, LGA. In fact, when you are searching for Intel processors, you'll see different types, LGA 2011, LGA 1155, or 1156. That determines how many pins there are. Different sockets are not interchangeable. So it's not like this board can take any AMD processor. It can only take the ones that are AM2 or AM2 plus, not AM3 or AM3 plus, not F series. So there's plenty of stuff that won't fit in here even though it's made by the same company. So here is your CPU socket. What is another part that all computers must have?
RAM.
RAM. Random access memory. Yes?
Power.
Power, also power. We'll get to power. We'll do RAM first.
Screen.
Random access memory is the working memory of a computer. Now, a lot of times the CPU is described as the brain, right? What does a brain do for us? Yeah.
It both remembers and thinks.
Remembers and thinks. So it does the processing and the memory. We actually have to separate brain into a couple of different components. Really 3 different components. The processor, which does the processing, the computation, the thinking. The RAM, which is the short-term memory. And then a hard drive will give us our long-term memory, our way back memories. So if you're going to do a math problem like, let's say, 6 plus 3 plus 7.
16.
Oh,
Okay? 6 plus 3 plus 7. Everybody can do that in their heads, right? I hope. Maybe
16.
not. It's possible you can.
It's 14.
So 6 plus 3 plus 7.
It's not 14.
Yeah, I don't.
16 is your answer. You have to hold on to those 3 pieces of information, 6 and a 3 and a 7 and some addition signs, right? And then your mind calculates it. So you hold the information in your head here. You calculate it here. But if you were to come back to this class, let's say you've gone off to college and you've graduated and you come back in 5 years. If I said, what was that math problem I asked you on August the 16th? Would you remember that?
I don't even remember what the question was.
I remember that
My dad
today
has
is the
been
19th
interrupted.
and not the 16th.
Is it really?
so-
I'm gonna remember it now, but
So now I'll remember it screwed up.
Hey,
Right, it's the
you-
19th.
You could just look right there instead of getting out your phone.
I could. So chances are you're not going to remember, hey, remember on the 19th when I asked you what 6 plus 3 plus 7 was?
Of course.
So you have working memory,
What about people?
and then you have long-term memory, which is stored on the hard drive. Long-term memory, memories from your childhood, things that you will remember about this class in 5 years. It won't be that specific, but you'll remember some things. That's what your hard drive is for. Long-term memory, working memory in RAM, CPU for processing. Now, random access memory. The random is important here. Think about a hard drive with a spinning disk. Disk spins like this. It has a head that moves back and forth. Works like a record player. So imagine a record player. If you're going to move from one portion of the record to another, let's say that you want to skip the first 2 songs and go straight to the 3rd song. Can you do that on a record player, or do you have to go through the first 2 songs to get there?
You can just lift up the needle and move it to the first.
Yeah, you can just lift it up and go. Now, the start of that song, let's say that your record is oriented like this, and the start of the song is over here, but your needle is over here. You do have to wait for that disc to come around halfway before the first note. So it's partially random because you can choose where on that record you want to start, and it's partially linear because the record does have to turn to get to where the needle is. What about a cassette tape? Do you have to go through the first 2 songs to get to the 3rd?
Yes.
Yeah, it's entirely linear. There is no random there at all. You have to fast forward. You can speed up the process, but you can't just jump right to it. So old tape drives, and we still use tape drives for backups today, are linear. That makes them slow. For some data, like backups, it doesn't matter if it's slow. We just want it to be cheap. With hard drives, we want it to be fast and cheap. So they use a partially random with that head that moves back and forth, and partially sequential or linear as the disk rotates. Now that disk rotates in a standard PC at 7,200 RPMs. It doesn't have to wait very long. It has to wait, okay, what's 7,200?
Divided by 60.
7,200 divided by 60.
Is 120
Okay, so 120 rotations per second.
divided by 60.
So it's going to come around every 1/120th second. Let's do 1 divided by 120. We'll get a decimal.
20. Is 0.0083.
All right, so 0.008 of a second, that thing is ready to receive data. That's pretty fast, but it's not as fast as 0.0000000, right? So RAM is like that. We can access any section of RAM just as fast as any other. That's not true on a hard drive or a record player. We have to wait a little bit. Certainly not true on a cassette tape. We have to wait a long time. Now, if the data is already queued up where we want, let's say that the data is queued up on the third song on a cassette tape. We hit play, third song starts playing. We didn't have to wait at all. So cassette tapes are fine if the data is queued up where we need it. But memory, short-term memory, doesn't work that way. Let's say that your computer boots. You're sitting in Windows, and then you launch Microsoft Word. And so you're working on a document. And then you launch a game, and you're flipping back and forth between the game and the document. That thing has to remember a whole bunch of stuff, right? Does it need to remember your tax return that you e-filed 2 years ago?
Yes.
No.
Not right now,
It'd be
right?
helpful.
We don't need that in memory. But we do need operating system files for Windows. We do need running stuff for the game. We do need running stuff for Word, all working at the same time right here in RAM. If you flip from the game back to Word to work on a, to add another paragraph, you don't want to rewind the cassette tape to get to Word, right? You just want to, bam, you're at Word, you're ready to rock. That's because Word, when it's running, is stored in short-term memory, random access memory. Because it's random, we can get to Word, which is stored over here, to the game over here, to, you click the Start button to launch something new, Start menu comes up immediately because it's stored in memory over here. So it can be stored anywhere, and anywhere we go to on RAM is just as fast as going to anywhere else, which is almost, but not quite true on a hard drive, and is certainly not true on a cassette tape. So that's working memory. A computer's speed is usually measured in megahertz or gigahertz of the processor, right? A Core i7 running at 3 gigahertz. But here's the problem. That is but one measure, and it does not measure the amount of work that a computer can do. It simply measures how many cycles per second this thing can process data. 3 billion bits of data can go through that thing every second, and that's a lot. But if it has 4 cores, it's actually 3 billion times 4. If it has 2 cores, it's 3 billion times 2. So the speed alone is not a good enough measure of how much work your computer can do or how fast it is. You take speed, you take number of cores, you take amount of RAM. Let's say that your computer has a ridiculously low amount of RAM, like 128 megabytes. That's very little RAM at all. 15 years ago, that would have been an exceptional amount of RAM. But when we boot Windows 7, for instance, it needs a gig of RAM just to store its operating system files in. What happens, do you think, when we hit that 128 megs and we're out of RAM? Yeah.
It starts either not opening more programs or storing stuff in less efficient ways.
Okay. And there is a particular less efficient way that it will store things.
On the hard drive?
On the hard drive, in a swap file. So a swap file is a special place on the hard drive, special file, that's treated like RAM. But a hard drive is so much slower than RAM, it's not even funny. All computers, all modern PCs, Windows, Linux, Mac, are all going to use a swap file or a swap partition. So let's say that you have a moderate amount of RAM, like 1 gig. 1 gig's fine, you can run Windows on a gig of RAM. But you run Windows and you launch Word and you launch your game. So suddenly you launch the game. And now you've filled up your gig and then some. So what it does is it starts writing the stuff where Word was to the special file on the hard drive, saying, hey, don't forget this, right? You have bad short-term memory. What do? You write it down. That's what it's doing. It's writing it down. Yeah.
Since RAM and SSDs are both flash memory and they're very fast, could you just have like a gig of RAM and have a very large swap file?
SSDs are still not nearly as fast as RAM, and the reason is twofold. One, the chips that they put in them just aren't as fast, but especially the bus. So RAM runs through your north bridge to your processor. This is all a very, very fast and wide pathway. Your hard drive, which connects to the SATA ports, is not. So this is a bottleneck for you. So even if you had a super fast SSD, not really. Now you can get some SSDs that plug into your PCI Express 16 slot, which does go through the north bridge. That's going to increase your performance by a huge amount, but still not quite like RAM will. I think ultimately we may get there, such that RAM would become obsolete and everything is just stored randomly in a super fast SSD-like thing eventually, but I think we're maybe 20 years out from something like that. And that will require reimagining the architecture because RAM will be not needed. So, yeah?
Is that what ReadyBoost is?
Yes, ReadyBoost essentially uses a USB drive like a swap file, like its RAM. And it's better than writing it to the hard drive as long as the USB drive is fast enough. And the other problem with putting it to your hard drive is that, let's say that you've got Word in the game, right? The game launches, so it has to start storing some Word to the swap file, start writing it down. Well, now it's doing two things. It's reading from RAM to write to the hard drive, while simultaneously reading from the hard drive your game to write to RAM. So you're doubling what your hard drive has to do, which makes you effectively twice as slow. So if you can put it on a ReadyBoost drive, yes, you do increase better than a swap file, but still it's a far cry from more RAM. So you've got a gig of RAM in here, and an 8-core, 3.4 gigahertz Core i7 overclocked to Jesus, not going to matter. Your RAM is a limiting factor. Your computer will suck with only 1 gig of RAM and a processor like that. You throw 4, 8, 16 gigs of RAM at it, and now it can remember everything. So Windows boots, and it stores all of its operating system files in memory. And Word starts, and your game starts, and it hasn't put anything to the hard drive. So you start another game, right? And every time you switch back and forth between those applications, it just pulls it out of RAM. So it's super fast. So RAM is often overlooked when upgrading a computer. People think about, let's buy a new computer so we can get a better processor. You're having problems? Stick more RAM in your machine. It's the first thing you want to do. Because ultimately, the play between your CPU and your RAM is going to give you the ultimate amount of work that your computer can do over a given amount of time. Does that make sense? Cool. We talked about hard drives. We're talking about hard drives a lot. Hard drives don't connect directly to the motherboard themselves. They require a cable as a go-between. So the processor plugs right into the motherboard. The RAM sticks right into the motherboard. The hard drive doesn't. The hard drive doesn't connect directly to it. It has a cable. There are two kinds of cables to connect hard drives. Old IDE has 40 pins, technically 39 because this one is blank, but it's considered a 40-pin connector. So IDE is flat, big, it's a ribbon cable. You can put 2 devices, 2 hard drives, or 2 old CD-ROM drives on one cable, as long as they have the connectors for it. So one port here can handle 2 devices. SATA, Serial ATA, is the newer version. Anytime you build a computer, this is the only one you want to use. This is included at this point for legacy devices. If you have an old hard drive that you need to read, you can throw it on there. Anything you're going to build is going to be SATA. There are different speeds for SATA. The current top specification is 6 gigabits per second, so SATA 6 gigs. Before that, SATA 3 gigabits per second. Before that, it was 1.5 gigabits per second. These are all compatible with each other. If you have a SATA 6 gigabit port and a 3 gigabit hard drive, they'll work, but it's going to work at the slower speed, 3 gigabits. The opposite is true. If you have a 3 gigabit port and a 6 gigabit hard drive, they'll work, but it'll still only be 3 gigabits, the lowest common denominator between them. SATAs can only have 1 device per cable, hence serial ATA happens in serial. These are also known as PATA, parallel ATA, because we can run 2 devices in parallel on the same cable. So we're going to need to know about this, but we're going to concentrate on this, serial ATA. SATA devices, hard drives, for sure. CD-ROM drives or other optical drives like DVDs, Blu-rays, also connect via SATA. Those are going to be really the only two things that you have. Now, when I say hard drives, I also group SSDs, solid state drives, in there as well. Hard drives we usually think of as spinning disks, and for large storage that's still what we use most of the time because they're cheap. But solid state drives are really coming down in price, majorly. They're down to about 50 cents per gig now. Now, that's still about 5 times more than a spinning hard drive. So it's a big jump. But your performance increase is huge, or can be huge, I guess I should say. Much like RAM, solid state drives can read any bit because it's stored on chips rather than a spinning disk. So they can read any bit as fast as any other. If you're asking for lots of different data at once, it's going to be very fast. If you're writing data to different places at once, very fast. But imagine a sequential read. Imagine a hard drive or a record player going around. If what you want is that song from beginning to end, and it's already in line, it's not any faster to be able to randomly access the last part and then the middle part and then the 3/4 part and then the first part, right? You're going to be accessing it first, second, third, fourth, fifth. So a hard drive, a spinning hard drive, is just as fast for a sequential read. The problem is most of our stuff isn't sequential reading. When you boot up Windows, Windows is going to look at 100 different files, little helper files here and there in the kernel. It's going to load stuff from all over. And when it does that, it's drawing it from different physical places on your hard drive. So an SSD will make you boot faster. Plug an SSD into here, you're going to see a performance increase, most likely, for most applications.
You plug it into what port?
To the SATA port.
Oh, wow. Wow. Cool.
So hard drives, long-term storage. Yeah.
Why is when you say SATA, when you like say what it actually is, why does ATA not also get words? What does that mean? Is it just,
I think because nobody ever refers to it as
Just like
what
it's-
ATA actually stands for.
It's
We
like,
can look it up.
It's SATA or serial ATA.
Serial ATA. See, you search SATA, it comes up serial ATA.
It's so weird.
Serial ATA, SATA, is a computer bus that connects host bus adapters to mass storage devices such as hard drives and optical drives. Replaces the older AT attachment, later referred to as parallel ATA.
What was he saying people should call it? What?
I was just wondering what ATA means.
So parallel ATA, originally AT
So
attachment.
ATA stands. Well, now we know what the last A stands for.
Yeah.
But what does
AT attachment, yeah. So it's
Artificial
for-
technology.
AT attachment.
It just doesn't explain.
Took us back to the same place.
So serial
IDE
AT
is
attachment.
integrated drive electronics.
As far as
Why
I
don't you
know.
just look up what does SATA stand for?
Isn't
It's
there
just
no-
a serial ATA.
What is the
Here we go.
whole name?
The middle AT. The PATA standard was originally conceived as PCAT attachment. So the last A is attachment. Because
Advanced
the primary
technology.
feature was direct connection to the 16-bit bus introduced by the IBM PCATs.
So it's serial
Serial
advanced
advanced technology.
Okay, so IBM's, one of their, the computer, when we say that, that an old computer is an IBM compatible, or an IBM clone, right, a PC clone, we mean the PCAT, which was IBM's big desktop computer, the AT. The AT is advanced technology, but it was ultimately designed for that. So if you want to say it's serial advanced technology attachment, you can, but I think we're so far removed from it now that that's not actually true. I think it really does mean serial ATA.
Okay.
But good question.
You'll learn some random crap.
A lot of people say SATA, that's fine too. I say
No, it's
SATA.
not.
Say,
SATA's got a D.
It's not gonna hurt you.
It's so
Santa.
Yeah, it's like more work to code.
You mentioned power. Power is one thing that our computer needs.
SATA sounds like
Things that plug directly into the motherboard get their power through the motherboard. The RAM, the CPU, those things are going to require power to work. They will get it through the motherboard. Things like the hard drive, which connect through this cable, do not get their power from the motherboard. They get it through their own separate independent power connection. Now the motherboard gets its power from the power supply. which plugs into this connector right here. This is known as the ATX P1 connector. The P1 is important. P1 means the primary, the first power connector. If you have a power supply, which we'll pull one out tomorrow, you have a power supply, it's got all kinds of wires dangling off of it. It has wires for the hard drive in a SATA power connector. It might have older Molex power connector for older hard drives. It might have these extra 4, 6, or 8 pin connectors to provide extra power for CPUs or video cards. But the main connector is the ATX P1, which is right here. This will have either 20 or 24 pins depending on which style it is. Almost all new ones are going to have 24 pins. Now that could come in the connector as a 20 pin and a 4 pin, and they connect together like this before they slot into the right place. So they could come separately as 20 plus 4 instead of 24. Either is possible. So most likely 24 pins in the ATX P1 power connector. Where does the ATX come from? ATX is a specification about motherboards, and there are different specifications including size, power requirements, and where the screw holes go so that you can connect it to a case. All of those are defined in the ATX specification. The size of an ATX motherboard has a range, but a standard ATX motherboard has sort of a specific size to it. You can have variances. This is an ATX motherboard. It is going to be reasonably large as motherboards go. There is also a micro ATX, which is about the same this direction, but only about yay wide. You can have fewer slots on a micro ATX, but micro ATXs are still very widespread. They do almost everything you need. One of the reasons for that is that there is everything you need built into the motherboard, like your sound processor, a lot of times your video processor. Does that mean you don't want a better one? No. If you're going to play 3D games, you're going to want a massive video card to slot into here. But most computers can handle basic video right out of the box. You throw a processor and RAM in it, and you're basically ready to go. You can use your add-on cards to add more capabilities, but a lot of people don't add more sound capabilities. Motherboards will have built-in surround sound to them these days. Even optical or coaxial digital outputs. You can connect to an amplifier and do Dolby Digital Surround or something like that. But you could upgrade that stuff. Yeah. Thanks. Just letting you know. If you intend to upgrade that stuff, you want lots of slots so that you can put that stuff in those slots. If you don't, you can go with a micro ATX motherboard, get a smaller case, maybe a smaller power supply. You can save energy, you can save room, and still have all the capabilities that you need. Now there's a ton of other size specifications. Mini ITX, very, very small, used for like home theater PCs. Something like the Apple TV might be a mini ITX motherboard inside. That would not have general capabilities for most computer applications. You wouldn't be able to stick a massive video card in there in order to play a 3D game. So a mini ITX works for some things like connecting to a television to watch movies, but not necessarily for playing games. So you're probably looking at either ATX or micro ATX in size. But we'll learn more about those sizes as we go through. For the most part though, ATX is this one, micro ATX stops about here. And it keeps going that way. All right, so what's this part?
CPU socket.
CPU socket.
RAM slot.
RAM slot. SATA port. Socket, slot, port. We're going to have other slots.
PCI.
For the most part, this is the only socket.
Sock lock.
We will have other ports and other slots though.
Socket ports.
Everybody pretty comfortable with the parts we went over today?
Yes.
Cool. We're going to pick up here tomorrow, go over the rest of the parts. We'll look at them in a real computer. Perhaps tomorrow we'll actually start ripping apart computers.